Hello and good morning. Okay, so we are in our last chapter, all right? Okay, chapter 9 on matrices. So matrices, I think you have seen matrices before, maybe during your secondary school, right? Madam, can I take attendance? E-leave. All right. Okay. Okay. Looking at one, can you see my shared slide? Shared note. Yes. All right. So you can actually represent a matrix. Okay. So in this case, we have three products um, and two things. Okay. Okay. So the numerical information can be represented into a rectangular block called matrix. Okay, so we have horizontally, okay, which is very natural. The vertical side is the column. Okay. Okay, row column. Okay, we have a very question in exercise 1. For each matrix, identify the number of rows and columns. Well, in A, there are 3 rows and 3 columns. The same for B. And then in C, we have 2 rows and 2 columns. Okay, we read by row first, only then by column. Okay, first, only then vertical. Okay. D, we have 2 rows and 1 column. Okay, D, we can see 2 rows and 1 column. And finally, in E, we have only one, or we have row, 4 columns. Okay, this is 1 row, 4 columns. What else? Okay, if you look at this representation, and the first number represent the location of the, while the second number represent the location of the column. Okay, as you can see, this is located in the first row and first column. This is first row, second column, first row, third column, and so on. Okay, or maybe considering 3, this is the element is located in the third row and third column. Okay. Since this and third column. Okay, now let's look at how to determine the order of a matrix. Okay. Well, that's very simple. Uh, the order of the matrix is simply M times N. Okay, so M will always be the number of rows. Okay, so row first, column second. This is the order, not multiplication. Okay, so for example, the matrix B, is a matrix of order 2 by 3. We call okay because it has 2 rows and 3 columns. Okay, it's 2 by 3. Or you can also write, it's also quite common to write this way. Hang on. It's quite common to write the order of the matrix, something like this. Okay, B is a 2 matrix. Okay, that's how you read the order of a matrix. Okay, 2 is just that it's very important for you to know that you must mention the number of row first by the number of okay, exercise 2. For each matrix, specify the order of the matrix. Okay, so the order of the matrix A, let's say this is, let's rename this matrix as A. Okay, so matrix A has order 3 by 2. Okay, because it has 3 rows and 2 columns. Okay, and then matrix B, 1 by 3, because 1 row and 3 columns, so it's 1 by the matrix C has order 3 by is everything okay until now? Any questions?
Okay, okay.
Okay, madam.
Continue with types of matrices. This is very straightforward, right? As you can see, the term itself, square matrix. Okay, so square matrix means the matrix has same number of rows and number of columns. Okay, for example, let this matrix A. As you can see, there are two and 2 columns. Okay, so it's a square matrix. Okay, the same for here. Let's say this is the matrix B, as it is a 3 by 3 matrix. Okay. Write an example of square matrix of 1 by 1. Okay, this is a matrix 1 by 1. But you name it A. Okay, let's say the element is 3. So, but you must remember this is in the form of a matrix. You should not write without the bracket. Okay, because without the bracket, it's not a matrix, it's just a number. And we have seen some examples on 2 by 2 matrix, 3 by 3 matrix. Okay, and then we have column matrix. Well, for a column matrix, it has exactly as easy as that. Okay, so column matrix the matrix has one column. Okay, or maybe for a row matrix, whenever a matrix has one row. As you can see, the shape of the matrix is either row. Okay, if you see this kind of matrix, it's a column matrix, or when you see this kind of matrix, this is a row matrix. Okay, basically in A, this is a column matrix. This is column matrix, row matrix, and C is one in a column matrix. Okay, next, I have a diagonal matrix. Okay, for a diagonal matrix, two requirements. Okay, so the first one, it must be a square matrix. Okay, and then this is actually not off, it's OF. That means the entry except the diagonal are zeros. As you can see, the entries except diagonal are zeros. So when only the elements on the diagonal are not zero. The rest are zero. Then we call this a diagonal matrix. Okay, this is off. This is off diagonal. That means except the elements on the main. Okay, and then we have triangular. The same for upper triangular, it must be a square matrix. And then element at the position where row is, well, that means B and C. B means the element on the lower side are zeros. Okay, and the element on the upper side are non-zero. That is upper triangular matrix. Okay, or if you have the other way around, if the lower side of the matrix are non-zero, then this is lower triangular matrix. Okay, so the lower or upper is referring to the non-zero, the location of the non-zero elements. Okay. Okay, if the non-zero are at the bottom, then it's lower triangular matrix. If the non-zero elements are at the upper side, then it's upper triangular matrix. Well, you know what? You need to just in case you are required to provide examples. Okay. Sometimes you are required to provide your own examples on maybe give a matrix, give a square matrix, an example of a square matrix, give an example of a lower triangular matrix, and so on. So you must know the term. Example here, these two both are lower triangular matrix, because as you can see, the lower side 0. Okay. Okay, but don't forget for lower and upper triangular matrix must be square matrices. Okay. Only then we can have upper and lower side of the matrix. Okay, for a not square matrix, we cannot really decide which part are the upper part and which part are the lower part. Okay, this is also the identity matrix. The identity matrix must also be a square matrix. Okay. Let's you can never have 3 by 2. Okay, this is not possible. Okay, this is not for identity matrix, a square matrix, either 2 by 2, 3 by 3, 4 by 4, and so on. Okay, even you can have an matrix of order 1 by 1, which is simply this matrix. Okay, this is the value 1. Okay, or this is quite common for your syllabus. Okay, for your syllabus, I would say identity matrix of order 2 by 2 and 3. Okay, or maybe sometimes 4 by 4. That's the most that will be the biggest order that you are going to consider, 4 by 4. Okay. So for an identity matrix, let's say we consider a 2 by 2 identity matrix. The element must be 1 on the main diagonal. Okay, the element must be 1 on the main diagonal. While for the rest must be 0. Okay, must be 0. Okay, or maybe if you are going to consider a 3 by 3 identity matrix, as you can see, all elements on the main diagonal are 1. Okay, the rest must be 0. Rest must be 0. It can't be any other values. Okay. Okay, and then we have null matrix. Well, null matrix is referring to the 0 matrix. But for a null matrix, it's not limited to square matrices of any size. Okay. For example, null matrix 1 by 1. The element will be single 0. Like this. Okay. A 2 by 2 null matrix, then you will have 0, 0, 0, 0. Okay. So in a null matrix, the elements are only zeros. Okay. Or you can also have a rectangular null matrix. As you can see, we have 2 by 3 null matrix here. So whatever the size is, you just fill in with zeros. That's all. Okay. Else. Okay, for each matrix, determine the types and order. Well, this is quite easy. Maybe I will post this on these questions. Okay. Okay. I hope well or and write on a piece of paper. Okay. For your own revision. Determine the types and order. Please do it now. I give 5 minutes. All right. After this class, maybe, I don't know, maybe in the evening or at night, I'll share quiz via Telegram, okay? Or maybe online learning. I'm not sure yet. Okay, but the quiz will cover anything that we are learning this morning. Two minutes more. I hope everyone is okay. Let's move on. In this slide, we have equality of matrices, and then what else? Trans of a matrix, and also matrix addition and matrix subtraction. Okay, I would say these four things are quite straightforward. Okay, equality, and transpose, uh, transpose, uh, matrix addition, matrix addition, matrix subtraction. Okay, all four things are very straightforward. You don't have to worry too much. I mean, if you are new to matrices. Okay, first look at equality. Okay, equality of matrices. Well, when we say equality, we are looking at whether two or more matrices are equal or not. That's all. Okay. Okay. For example, we are trying to compare the matrix on the left side, the matrix on the right side. Okay, and obviously you can see that both have same order, and also you can see the corresponding element are also the same. Okay, that means the first element is 4, the second element is 0, the same on the right side. So basically the first example and the matrices in the first examples are equal. Okay, and then moving on to the second example, obviously you can see that the order are not the same. Since on the left side it has 3 by 2, the order is 3 by 2, while on the right side it's 2 by 3 matrix. So obviously they are not equivalent. Okay, even though you might say the elements are quite similar. Okay, but since the order are not the same, then obviously they are not equal. Okay, so that's equality of matrices, as easy as that. If you are going to compare, for example, okay, let's look at B now. Let's look at B. Okay, what is the order of B of the matrix on the left side? The order of the matrix left side is 2 by 2. And the order of the right matrix is also 2 by 2. Okay, it's just that the way they write the element are different. But actually this is also 0. This is also 0.5. Okay, the same as this. Okay, 2 over 5, 2 over 5 is actually 0.4. Okay, so they are the same. And then 1 over 4 is the same as 0.25, and then the last element 3 over 10 is actually the same as 0.3. So basically they are the same thing. Let's say we name this A and B. You can conclude that A is equal to B. Okay. Okay, for the other questions, you can work on your own. Okay, what else do we have? Okay, you can also do example 2 on your own. Okay, given the matrices A and B, okay, if A is equal to B, determine the value of X, Y, and Z. Okay, and also you can do B. Okay, because it has given to you that the left side and the left matrix is equal to the right matrix. Okay, basically we understand equality of matrices. What's left for you is to do some exercise questions on that. Moving on, transpose of a matrix. This is also very straightforward. To transpose any matrix, you just change the order of the row to become the column to become the row. So, okay, let me demonstrate. Let's do now. Okay, so this is your regular matrix A, and we are trying to convert this into its transpose, so we can denote it by A transpose. We will write A small t at the top. Okay, so this is your regular matrix, and then you can convert that into its transpose. For example, let's consider this matrix 10, 6, negative 2, 6, 8. Okay, so this is your A. So what is A transpose? A transpose, what is the size of the matrix A? This is 2 by 2 by 3. Okay, when we transpose a matrix, the order will become 3 by 2. Okay, the order will become by 2. That means, okay, so this is your first row. Okay, now become the first column. Okay, then for the second row, now it will become second column. And don't forget the matrix sign. Okay, and as you can see now, it's 3 by 2. Then you transpose any matrix. Okay, let's do once again for B. B is 2 by 1. Okay, B negative 1. As you can see, this is a column matrix. When we transpose it, now it's first column. The column will now become the first row. As simple as that. Okay, so from 2 by 1, now it will become 1 by 2. Okay. Well, since C is a square matrix, C is 2 by 2, but since it's a square matrix, when you transpose it, it will still be 2 by 2, but the order of the elements will change. That means the first row will become the first column. Second row will become second column. Okay, row will become column will become row, or maybe you can just think of one thing. The row become the column. That's all. So that's a transpose. Transpose of any matrices. Now let's move on to operation of a matrix. Okay, first let's look at matrix addition. Okay. First thing first, in order to add two matrices, both matrices must have the same order. Okay. For example, matrix A 2 by 2 plus B 2 by 2. This is possible. This okay. Okay. Or maybe you have matrix C 2 by 3 plus matrix D 2 by 3. This is also okay. Okay. About A 2 by 2 plus C 2 by 3. Is this possible? No, this is impossible. Okay. In order to add two or more matrices, it must have it must be the same order for all matrices that you are going to add. Okay, and the addition is quite straightforward. Element will add this element. This element will add this element, and so on. Okay, you will add by element and one element plus another element in another matrix. Okay, let's look at some examples. Okay, calculate the sum. Calculate the sum of both matrices below. As you can see, both are 2 by 2, right? So the addition is possible. The answer is, okay, 1 plus 4. So the first element will be 5. Okay, this is A plus B. And then 4 plus negative 2. This is 2. 3 plus negative 1. This is 2. And finally, 2 plus 3, 5. Okay. Or maybe let's look at 3 Roman. This is E plus F. E plus F. So you add element by element. 3 plus negative 4. This is negative 1. 4 plus 1. This is 5. 0 plus 2. This is 2. 14 plus 0. This is 14. Okay. This is also possible because you can see that the matrix E has order 1 by 4, and also F is also 1 by 4. Since the order are the same, you can add the matrices. Okay, the same concept for subtraction. Tolak matrix pun macam tu. Size kena sama. Dan and the way you subtract the elements are similar to how you add the element for matrix addition. For example, G minus H. Okay, first thing you must check that you must check the order of the matrices. Okay, so this is 2 by 1 and this is also 2 by 1. Okay, you can see that both are the same order. So you can subtract. So 4 minus 7 is negative 3. 5 plus 1 is 4. Okay. And this is still 2 by 1. The same thing for addition and subtraction. After you add or after you subtract matrices, the order will be the same as the question. Okay. Okay, if you are adding 2 by 1 matrix, then the yield will also be a 2 by 1 matrix. Okay. Let's do time for 2 Roman. Okay, so what is the order of the matrix J? This is 1 by 3. This is also 1 by 3. So you can substitute. So J minus K is -1 minus 0, then it's -1. 5 minus 1, then it's, and 4 minus 2 is 2. And you can see that the result is still a 1 by 3 matrix. Matrix addition. Okay, before we end our class today, let's look at the properties of matrix addition and subtraction. Okay, matrix addition are commutative. What does it mean by commutative? That means A plus B is the same as B plus A. Okay, but for subtraction, it's not commutative because A minus B is generally is not equal B minus A. And then matrix addition is associative. That means if you addition of A plus first is the same as the whole thing here will be the same if you find B plus C first. Okay, if you are going to add for 3 matrices. However, matrix addition is not associative. They might not be the same. Matrix addition has the identity property. Well, A plus 0. That means any matrix A plus a null matrix is the same as null matrix plus matrix A, the same as A. This is okay. Okay, and then for matrix subtraction is not identical because A minus 0, you will get A, but for a null matrix minus negative A, you will get A. Okay, maybe, okay, let's demonstrate. Okay, let's say this is your matrix A, 1, 2, 3, 4. Okay, what happens if you minus the null matrix? You will get 1, 2, 3, 4. Okay, which is the same here. Okay, but what about a matrix minus A? You will get -1, -2, -3, -4, and -2, -4. This is negative A, and you can see A is not equal to negative A. Okay, but addition, no problem for addition. Okay, no problem for addition. All right. I think I'll stop here for today, and give me some time to do questions on whatever we have learned until now. Okay, if you are familiar with multiplication, matrix multiplication and the rest, you can proceed on your own. Okay, but I will cover that maybe maybe by recording some videos, or we might be continue the lesson on Thursday. All right, but I can provide video before Thursday because we are going to have our test too soon. All right. I think that's all for today.